Okay, welcome back. This is Mr. Hassan's Maths channel. I'm answering question number 3 from the October 2024 International A-Level Mechanics M1 exam. And this question here is about vectors. And we're told in this question, I and J are horizontal unit vectors and position vectors are given relative to a fixed origin. So a ship A is moving with constant velocity. At 1 p.m., the position vector of A is 25i plus 10j. At 3 p.m., the position vector of A is 55i plus 34j. At time t hours after 1 p.m., the position vector of A is RA kilometers. So it says, show that RA equals 25 plus 15ti plus 10 plus 12tj. So now, here we have to find basically the position vector of this ship. And the formula for the position vector of an object that is moving at a constant velocity is as follows. So the position vector of the object is equal to R0 plus V times T. R0 is the position vector, and position vector means relative to the origin, okay, when time is equal to 0. And V means the velocity vector. That's the speed and direction in which it's moving. The magnitude of the speed and the direction in which it's moving is the velocity vector. That tells us about that. And T is the time, T stands for the time in hours. In this case, in hours. Okay, so now we know that we are considering t hours after 1 p.m. Okay, so 1 p.m. is our starting point. So we can say t equals 0, okay, at 1 p.m. That's when we're starting. That's a reference point. Okay, so we can say that the position vector of A at 1 p.m. is 25i plus 10j. That means R0 is 25, 10. Now I'm going to use column vectors and then I'll put everything back in I and J at the end. Okay, now at 3 p.m., okay, that's when time equals 2. Okay, that's at 3 p.m. Okay, now we know the position vector of A at 3 p.m. R at 3 p.m. Is going, so that's R2 basically, is going to be 55i plus 34j, right? So what we can do, we can try to find what the velocity vector is, okay? So I know what R is, R2 is, I know what R0 is, and I want to find what V is, okay? And I know what T is here, okay? In this case, we know T is 2 hours. So we can say that, right, so that's R0, that's R2, and of course the time is 2, right? So we can just use this formula here. We can say that R2, which is 5534, is equal to R0, which is 2510, plus V times T, okay? So it's going to be 2 times V. So if you want to find what the velocity vector is, we have to subtract these two and divide by 2. So the velocity vector is a half of 55 minus 25, 34 minus 10. So the velocity vector is going to be a half of 55 minus 25 is 30, that's going to be 15. And 34 minus 10 is 24, half of 24 is 12. So this is the velocity vector of A. Okay, so that means the position vector of A is going to be R0 plus VT. So R0 is 2510, plus V, which is 1512 T. Okay, if you want to write this in terms of I and J, okay, you have R, A is going to be 25 plus 15T, 25 plus 15T. That's the I component. plus, and you got 10 plus 12 t j. That's the j component. That's the horizontal component, and that's the vertical component, and that's in kilometers. That's the position vector of A. Okay, RA equals 25 plus 15 ti plus 10 plus 12 tj. Okay, and there's the answer to that. We don't need the kilometers bit actually, so that's fine. Oops. Okay, I'll just write it in the same format that they told us to write it. As always, I much prefer to use column vectors, and in the end I just write them in the form. If they tell us to write in terms of A and J, I write it in terms of A and J. If the question is given in this I and J form, that's what I do. Okay, then it says the speed of A is v meters per second. Find the value of v. So we know that the velocity of A is given by the vector 15, 12. That's the velocity of A. Okay, so the magnitude of the velocity of A is equal to its speed. So it's going to be the square root of 15 squared plus 12 squared, which is going to give us, that's going to be 3 times 5. It's going to be, let's have a look. So we got 15 squared plus 12 squared. That gives us 3 root 41. Okay, now one of the things we have to be careful about here is that in this question, we've been given our units as kilometers and in hours. Okay, so the vectors that were given before were in kilometers and in hours. Okay, the distance was in kilometers and the time was in hours. And they want us to find the speed of A in meters per second. It's a bit of a sneaky one here. And to be honest, it passed me by the first time. Okay. Normally they would put something like that in bold type, but you've got to be very careful. Okay. Something that it's easy to, especially in an exam situation. I think the examiner who snuck that in there, a bit nasty to be honest. Anyway, so this is in kilometers per hour. Okay. And we want to change from kilometers per hour into meters per second. How do we change from kilometers per hour into meters per second? Some people memorize. I don't like memorizing. So it's like kilometers per hour. Okay, so we're going to change kilometers to meters. Okay, by multiplying by 1,000. Okay, and we change hours into seconds by multiplying by 60 squared. So we're going to take 3 times root 41. We're going to multiply it by 1,000. That will change it from kilometers per hour into meters per hour. And then we divide by, why divide? Because it says per hour. So it's the denominator. So we divide by 60 squared. So it's going to be divided by 60 squared. So that's going to give us our answer in the correct unit. So we have 3 root 41 times 1,000 divided by 60 squared. So that gives us 5.3359, 5.3359, which is 5.34 meters per second. Okay, so there's the answer to part B. The speed of A is 5.34 meters per second. All right, a ship B is moving with constant velocity 20I minus 6J kilometers per hour. At 1 p.m., the position vector of B is 35I plus 51J. At 2:30 p.m., B passes through the point P. Show that A also passes through the point P. Okay, so we know the position vector of A is given by, as we were told to show, 25 plus 15 Ti, 25 plus 15 Ti, and 10 plus 12 tj. 10 plus 12 tj. That's a position vector of A, any given time t. Right? Now for B, it has a velocity of 20I minus 6j. So for the position vector of B is going to be, its position vector first is 35I plus 51j, and its velocity vector is 20I minus 6j. So we can write this, if we want, as 35 plus 20t, that's the I component, and 51 minus 6t, that's the j component. That's the position vector of B at any time, okay, from 1 p.m. Okay, that's initial position vector. Okay, remember it's R equals R0 plus VT. So R0 is this, okay, and V is this. Okay, so now it says at 2:30 p.m. B passes through the point P. So when time is equal to 2:30, okay, that means from 1 p.m. that's 1.5 hours. Okay, when 2:30 p.m. is basically when time is equal to 1.5. The position vector of B is going to be 35 plus 20 times 1.5 I, and 51 minus 6 times 1.5 j. So that's 35 plus, that's going to be 30, that's 65. Okay, I, and 51 minus 9, which is going to be 42j. Let me just make sure I didn't make a silly mistake there, which I sometimes do. So 35, sorry, plus 20 times 1.5. I'm making more mistakes on the calculator. Okay, times 1.5. See what's going on here? I don't know. All right, that gives me 65. Good. And 51 minus 6 times 1.5, which gives you 42. Okay, that's fine. So that's the position vector of B, okay, at 2:30 p.m. Okay. Now, the position vector of A. Okay. We want to show that it passes through this point. Okay, does it pass through this point? It doesn't ask us to say, does it pass through this point at the same time? It's just saying it passes through P. So position vector of A is given by 25 plus 15t, 10 plus 12t. Now, if it does pass through this point, then there's going to be a value of t, which will give us 65, 42, and it should be the same value of t for both the I and j components. So if we have a value of t that solves this equation, and the same value of t solves this equation, then we know that A passes through the point. So if we solve this equation, we have 15t is equal to 65 minus 25. 15t is equal to 40. So t is equal to 40 over 15, which is the same as 8 over 3 hours. Now, if we get the same solution for this, 8 over 3 hours, then we know that A definitely passed through that same point. Okay? Not at the same time, but it passes through that point. So let's look at the other equation. 10 plus 12t is equal to 42. 12t is equal to 42 minus 10. 42 minus 10. So 12t is equal to 32. So t is equal to 32 over 12. 32 over 12, which is, if you divide by 4, you get 8 over 3. Okay, good. So as t equals 8 over 3 in both I and j components, therefore we can say B, a boat A, is it a ship or boat, what did you say? Okay, ship A, therefore ship A also passes through. Okay, this point, which is also passes through the point P. Also passes through P. Okay, so if the times came out to be different, okay, for, you know, the solutions to these two equations came out to different values of t, then we can say that A did not pass through that point. Okay, because the same value of t should take us to the the same values of the I and j components of that position. Okay, so that's how you answer part C. Is there a part D here? No. Okay, so that concludes this question here. Other questions that you have, you want to see from the same paper will be found in the playlist that will appear in the top of the screen at the end of this video. Other questions from the topic of vectors from M1 you can find in the playlist over here. You can subscribe to the channel by clicking on this link, and on the top here you can find a video which explains how to use my channel efficiently. Thank you for watching and see you soon.